welcome to Mathora. I'm Ms. B, and you'll be learning with me. Today, we're combining like terms. By the end of this lesson, you'll be able to identify like terms, combine like terms, and avoid the number one mistake. First, we're going to tap into what we already know, aka our prior knowledge. Then, we're going to get into the lesson, and after the lesson, I'm going to check for understanding. Now, let's talk about the basics. Little did you know, in the first grade, you were already combining like terms. It's just they were called numbers. You combined 1 and 1 and made 2, and you also combined 3 and 1 and made 4. The difference between then and today is we're adding a letter to the end of it, and that's called a variable. So what does like terms actually mean? Like means from the same family, and term means a number and a letter together. The number is what we call our coefficient, and the letter is what we call our variable. Let's use 3x for example. 3 is the coefficient, and x is the variable. Like terms are terms that have the same variable raised to the same power. That means they come from the same family. So like terms have the same variable and exponent, but the coefficients can be different. How do you spot like terms? Well, it's kind of like spotting a family member. Usually, when you run into somebody with the last name, the first thing you think about is, are we related? It's the same thing with spotting like terms. For example, we have 2x and 5x. They have two different names. We have 2 is 2 and 5 is 5, but they're still part of the x family, so therefore they can be combined. Another example is negative x and 7x. First, whenever we see a variable without a number, it is an imaginary 1. So we have negative 1 and a positive 7. The coefficients can be different as long as the variables are the same. So therefore, negative 1 and 7x is like terms. One more example, 4 and negative 9. Now, 4 and negative 9 does not have a last name, which means they are like terms. These are what we call our constants, our numbers, our basics. If the letters and powers match, they're in the same family and can be combined. If not, they stay separate. Let's go ahead and give it a try. Example 1, same variable, same family. Here we have 2x plus 5x. Well, they are definitely like terms. Now we need to combine our coefficients with the operation in the middle. 2 plus 5 is 7, and then we're going to add on x. Be sure to box in your final answer. Example 2, variables and constants. Here we have 3x plus 7 plus 2x. The first thing I'm going to do is highlight our like terms. So I'm going to highlight 3x, and I'm also going to highlight plus 2x because the plus sign belongs to the 2x. Now I know that I'm supposed to be adding. 3 plus 2 is 5, x, and then plus 7. Be sure to box in your final answer. Example 3, negative coefficients. We have negative 6a plus 2a. They are definitely part of the same family. However, we have to know how to combine integers. Here's a reminder of the integer rules. Negative 6 plus 2 is negative 4a. Be sure to box in your final answer. Different families. Example 4. We have 4x plus 3y. 4 is part of the x family, and 3 is part of the y family, so they have to stay separate. 4x plus 3y equals 4x plus 3y. Be sure to box in your final answer. Example 5, constants only. 12 minus 5 plus 3. Now we're back to the basics, but it's really important that you know how to add and subtract your integers and follow PEMDAS. So first, we need to do 12 minus 5. 12 minus 5 is 7, and then plus 3 is going to give us our final answer of 10. Be sure to box in your final answer. Last example, example 6. This is called a mixed order example assessment style. This is what you're going to see more often. 5x plus 2 minus 3x plus 7. I'm going to highlight my like terms. 5x minus 3x equals 2x. And then I'm going to highlight plus 2 and also plus 7. Positive 2 and a positive 7 makes a positive 9. So I'm going to write positive 9. Our final answer is 2x plus 9. Now, the number one mistake when combining like terms, some might say this equals 7x, and it doesn't, because the second term is just a 4 and it does not have a last name at all, so therefore it cannot be combined with someone in the x family. The final answer is going to be 3x plus 4. Another example, x plus x squared, some might say it is 2x squared. First, let's talk about where we're getting the coefficient 2 from. In front of every variable that doesn't have a number is an imaginary 1. So this person did 1 plus 1 is 2. However, they're still wrong, because x and x squared is kind of like your name being Will versus William. Two totally different names. So therefore, we cannot combine them. They have to stay separate. Now it's your turn to show me what you understand. Pause the video and simplify the expression, and I'll be back to check your work. The first thing you should have done is highlighted your like term. So we have a positive 6x and a positive 2x, so therefore we're going to add them together. 6x plus 2x equals 8x. So now I know the answer choices in between A and C. What we have left is a negative 4 and a positive 9. So negative 4 plus 9, remember our integer rules, is going to give us positive 5. So the answer is A, 8x plus 5. Before you go, check out the exit ticket right here. Like the video if this lesson helped, subscribe for more math made clear, and leave your response in the comments. I'll see you next lesson.